Welcome to The Explainer. Today, we are putting on our detective hats for a pretty fascinating chemical whodunit. We've got a mystery compound, a couple of reactions, and really, just a few grams of evidence to work with. So let's open the case file.
I mean, it's a classic scenario, right? You've got some unknown substance sitting on your lab bench, and you have to figure out what in the world it is. So where do you even begin? Well, you start by using the fundamental laws of chemistry as your magnifying glass.
And our case today involves two unknown elements. Let's call them our prime suspects, X and Z. They're hiding inside a compound, and it's our job to follow the clues, run the analysis, and ultimately reveal their true identities.
All right, every good investigation starts with the case file, so let's lay out everything we know so far.
Okay, here are the hard facts. We are starting with just over 7.5 grams of some substance with the formula XZ-O3. Now, when we heat this stuff up, it breaks down. It gives us a known amount of pure oxygen gas and this new, simpler compound, XZ. These little numbers, these masses, they are our first real clues.
Now, this balanced chemical equation, this is basically the rule book for our entire investigation. It tells us the exact ratio that these things react and form in. See that? For every 2 units of our starting stuff, we get exactly 3 units of oxygen and 2 units of our new compound, XZ. That ratio, that is going to be absolutely crucial.
You know, with any good mystery, you need that first break in the case. And for us, that break is the oxygen. Why? Because it's the only substance in this whole mess that we actually know the identity of. That makes it the key to unlocking the rest of this puzzle. So, here's our 3-step game plan. First, we're going to convert the mass of our oxygen from grams into a way more useful unit called moles. You can just think of it as a chemist's version of a dozen. Then, we'll use that reaction ratio from our rulebook to figure out how many moles of XZ we made. And finally, that will let us calculate the molar mass of XZ, our first major lead.
So after running the numbers on our evidence, converting those grams of oxygen to moles and applying our reaction ratio, we get a really critical piece of information about our mystery compound XZ.
We find out it produced precisely 0.0460 moles. Now, I know that number might not look like much, but in chemistry, believe me, it's a golden ticket. It's the key that connects the world of mass that we can actually weigh to the hidden world of atoms and molecules.
And now we can use that golden ticket to find a really important physical property, the molar mass. It's basically the weight of 1 unit of a substance. All you do is take the grams, which we have from our evidence, and divide it by the moles, which we just figured out.
And boom, there it is. The molar mass of our compound XZ is 119 grams per mole. This is huge. It's like getting a clean fingerprint from the crime scene. We don't know who it belongs to yet, but it's a totally unique identifier for the combined identity of X and Z.
Okay, with our first lead secured, it's time for phase 2 of the investigation. This lead takes us to a second experiment, one that's specifically designed to isolate one of our suspects.
So here's what happens. Our mystery compound XZ gets mixed with silver nitrate. This reaction basically forces X and Z to split up. Z decides to pair up with the silver, and it forms a new solid AgZ. And critically, we know exactly how much of it was made.
And you know what's really beautiful about this reaction? Its simplicity. The equation shows a perfect 1-to-1 relationship. So for every 1 mole of XZ we start with, we get exactly 1 mole of AgZ. Since we already know we have 0.0460 moles of XZ, well, we have to have produced 0.0460 moles of AgZ. No complicated math needed. Gotta love that.
So using the exact same logic as before, just dividing the mass of AgZ by the moles we just found, we calculate its molar mass to be 188 grams per mole. Oh yeah, the plot is definitely thickening. We are getting so close to unmasking one of our suspects.
Okay, this is it. This is the moment we've been working towards. We have all the evidence we need to finally put a name to one of our mystery elements.
So here's where it all snaps into place. We know the total mass of that AgZ compound, right? It's 188. And we also know the mass of one of its components, silver, because we can just look that up on any periodic table. So how do we find the mass of our unknown Z?
Yep, it's really as simple as that. The total mass minus the part we know equals the part we don't know. Let's do the math. And that little bit of subtraction gives us 80.1 grams per mole.
This number right here, this is the chemical fingerprint of our first suspect, element Z. Now we just need to find a match in the database. And a quick scan of the periodic table, our list of usual suspects, shows a molar mass of 79.9 for bromine. That is a match. Our mystery element Z is bromine. Fantastic work, detective. 1 down, 1 to go.
Now that we know Z is bromine, identifying X is just the final piece of the puzzle. This should be pretty straightforward.
We just have to circle all the way back to our very first clue, the molar mass of the compound XZ. We found it to be 119. We now know for a fact that about 80 of those grams per mole come from bromine,
which leaves just 39 grams per mole for element X. And one last look at the periodic table confirms it. The element with a molar mass of 39.1 is potassium. Our second suspect, X, is potassium.
And with that, the case is officially closed. Let's just review the final report, shall we?
So here it is, the final rundown. Element X is potassium, element Z is bromine. That means our original mystery compound was potassium bromate, which decomposed into potassium bromide and oxygen. All the numbers line up. It's a perfect solve.
You know, this really gets to the heart of what we just did. We didn't just have the answer handed to us, but by asking the right questions one after the other, what are the moles, what's the ratio, what is the molar mass, we followed a perfectly logical path straight to the solution.
And it really makes you think, doesn't it? This methodical process of deduction, it's not just for problems in a textbook. This is exactly how forensic scientists identify unknown substances at a crime scene. It's how researchers develop new medicines and how engineers create groundbreaking new materials. It all just comes down to following the evidence one logical step at a time.